Good morning, third grade. Today we are doing page 527, numbers 6 through 13. Before we begin, keep in mind that this lesson is all about comparing fractions. We might see fractions with the same numerator, we might see fractions with the same denominator, or we might see fractions with completely different numerators and denominators. So we are combining the two lessons that we've been working on before this with the same numerator and same denominator, and we're taking it a little further than that. So if you need fraction bars or fraction tiles, please help yourself to them. Also remember our butterfly method always works really well. So keep those two things in mind as we work through these problems. Here we go. As we are working through numbers 6 through 9, pay attention to the directions. It says write the strategy you used. So the strategies that we've learned so far are the butterfly method, same numerator, same denominator. You could also write fraction tiles. Right, using fraction tiles or drawing a model would have helped you as well. So that is a strategy that we're using too. Okay, number 6, you should have the less than sign for number 6. 1/2 is less than 2/2. The most obvious strategy that you could have used was same denominator strategy. We see 2's in the denominator. So remember, when the denominators are the same, you look up at the numerator. The greater the numerator, the greater the fraction. So for me, that's the strategy I would have used, same denominator. Now that doesn't mean that you could have used something different, like the butterfly method, or fraction tiles, or drawing a model. All of those are equally as good, but for me, I think the most obvious one was same denominator. Your strategy might be slightly different. That's okay. As long as you got that less than sign, that's all we're after. The answer to number 7 is greater than. 1/3 is greater than 1/4. The most obvious strategy is same numerator. When I look in the numerators, I see 1's. Remember, when the numerators are the same, you look at the denominator. The smaller the denominator, the greater the fraction. Because they're the same size whole, thirds would be bigger than fourths because there are less pieces. So we need the greater than sign. I put same numerator. If you didn't use that, if you used the butterfly method or fraction tiles, that's perfectly acceptable as well. The answer to number 8 is less than. You may jump ahead now if you got that. If you didn't get less than here, a really great strategy to use would be the butterfly method. Now when we use the butterfly method, we're going to draw our butterfly wings. 3 times 5 is 15. 6 times 2 is 12. 15 is greater than 12. That means this fraction right here, 5/6 is greater. You could have also used fraction tiles. You could have drawn a model as long as the holes are the same size. So the most important piece here is that you got the less than sign. If your strategy was different, that's okay. For number 9, you should also have the less than sign. If you got that, jump ahead now. To get less than, a really good strategy would be the same numerator strategy. I see here both of the numerators are 4. Therefore, I can look down at the denominator. The smaller the denominator, the greater the fraction. So 2 is smaller than 6, so therefore if I have a hole and it's cut into 2 pieces, those halves are going to be a lot bigger than the 6ths would be. So my 4/2 will be greater. Right, number 10 and 11 are going to be very tricky for us to check because there's more than one possible answer. So please know the answers that I give are not the only answers. You did need to draw to justify your answer. When we justify something, we're proving it. So you needed to draw a model to prove that the fraction they gave is equal to your fraction. So before we get checking, please make sure that you did both of those things, draw and put your fraction. Okay, we want a fraction that is less than 5/6 for number 10. So I chose 2/6. Other possible answers could be 4/6, 3/6, 1/6. You could have also used the same numerator strategy, and you could have done 5/4, 5/3, 5/5, and so on. So again, 2/6 is not the only answer. So if we look here at my model, notice how both of my holes are the same exact size. We cannot compare fractions if the holes are not the same size. So I split both of these into sixths. This first fraction bar shows 5/6. Second one shows 2/6. We can clearly see, this is a visual problem now, that 2/6 is a lot less than 5/6. Make sure you had both a fraction and you drew a model with the same size holes. For number 11, we want a fraction greater than 3/8. So I chose 6/8. You could have also done 4/8, 5/8, 7/8, 8/8, and so on. If you used the same numerator strategy, you could have done 3/7, 3/6, 3/5, and so on. My model, notice how both of my holes are the same size. I chose to do circles this time instead of rectangles. That's perfectly fine. I split both holes into eighths. Here we see 3/8. Here we see 6/8. We can see visually 3/8 is less than 6/8. Make sure you have the model and your fraction. The answer to number 12 is Seth. Jump ahead now if you got Seth. Now let's take a closer look at how we got Seth. So the question we're answering here is who gets the most orange juice. So we want to figure out which of these three fractions is the greatest. So I have 3/6, 1/6, and 2/6. Now I notice all three of these fractions have the same denominator. There's a 6 in each of the denominators. So when the denominators are the same, I look up at the numerator. The greater the numerator, the greater the fraction. So I have 1, 2, and 3. 3 is, of course, the greatest numerator here. So 3/6 would be the greatest fraction. Now be careful. 3/6 is not the answer. We want to know whose cup had 3/6, and that was Seth's. So that's where we got the answer of Seth. Moving on to number 13, you may pause the video right now and compare your explanation to mine. Keep in mind that our wording might be slightly different, but you had to have the same idea. You also should have drawn a picture to help explain your answer. So here we can see we have eighths, we have sixths. We've shaded 5 out of the 8 and 5 out of the sixths. So this model supports our explanation. When the denominator is smaller, like sixths, the pieces are actually bigger because we have the same size whole, but we have less pieces inside. So sixths are greater than eighths. So therefore 5/6 is greater than 5/8. If you need to rescan this math on the spot QR code and take a closer listen to Professor Berger as he does this problem, or not this exact problem, but a very similar problem, he goes a little bit further into detail with a very similar problem to this. So if you need to rescan this and listen to what he has to say. All right, my friends, very good job today. You may look up on the board for your next activity.